Hello everybody, welcome to this vlog. My name is Satya. Today I will be discussing about home router NAT. So as discussed in many classes before, home router has a LAN switch and a WAN port. So LAN will be the private network, LAN network, local area network, and WAN will be the connection through which we access the internet. So we can't expose our private IP addresses. That is one reason, and the other reason is why we use a public IP address, which is different than the private addresses. Is one reason because of privacy, and we can block a lot of packets from the external malware or any unwanted packets coming into our router. The other thing is, if you keep assigning an IP address to each device on the LAN, then we will surely would have run out of IPv4 addresses by a long time ago itself. So that is one reason to make the IPv4 addresses still be useful or used in the internet. We use NAT. It is called as Network Address Translation. So the full form of NAT is Network Address Translation. As the name suggests, the full form of the NAT suggests, it will translate the private addresses to a public IP addresses. So now, what are the different type of NATs? Because each router will be configured with different type of NATs. There are two ways we can distinguish NAT types. One is depending upon the NAT, how it translates to the public IP addresses. These are called as NAT translation types. And the other one is NAT behavior. So after translation, how NAT behaves. So depending upon that, you can categorize certain NAT types. So first let's discuss about NAT translation types. The first NAT translation type is static NAT, which is one-to-one mapping, which is called as static NAT. In static NAT, there is a fixed private to one IP address, public address. All the packets on the LAN side will be translated to one public IP address. The port will still be retained, it will not be translated. It will be one-to-one mapping of the IP address. For example, if you are using 192.168.0.2, 0.3, 0.4. These are the three clients which are connected to the LAN, and they have a private IP address as 192.168.0.2 and 192.168.0.3. So then there is direct mapping of these IP addresses to a public IP address. Right? So there is a static mapping that is happening from 192.168.0.2 to public IP address. Right? So what is the disadvantage of static NAT? The disadvantage of static NAT is it is known to the external clients which connect to our home router that this is the IP address they will always use. For example, 192.168.0.2 maps to one public IP address. That is how it will always be. So the external clients not connected to home router but from internet, they can directly use the public IP addresses mapped to 0.2 to communicate with the internal client. So there is one-to-one mapping. And other thing is since there is one-to-one mapping, it is like IPv4 depletion will not be solved by this particular NAT because there is always one-to-one mapping. So number of clients you have, those IP addresses will have one-to-one mapping. For example, you have 5 clients, then you use 5 public IP addresses. So this is not solving the problem of avoiding IPv4 depletion. So it is very rarely used. So this can be used to host a publicly available web server in your LAN side. On the LAN side of in the private network, you can host a PC in Linux or in Windows, which has a web server running, HTTP Apache server, through which you can provide HTTP or web access to the external clients who connect from outside to this home router. So there is one-to-one mapping. Always external servers or external users want to access the website which is hosted in the LAN side will know what is the external IP address, since it is one-to-one mapping. So you understood static NAT is one-to-one. So each IP address, private IP address on the LAN side will be mapped to a public IP address, that is one-to-one. So it will not solve the IPv4 depletion problem. It is only used to mount your web server in the LAN side of the home router, right? So this is with respect to static NAT. Now how can we solve this problem? For translating the address, there is one more mechanism called as dynamic NAT. Instead of providing a single IP, each connection or each IP address on the private client using a single IP address, they will be given pool of public addresses. Pool of public addresses. So on the WAN side, you will get a pool of public addresses. So once you initiate from the LAN side, for example from here, LAN side, the private address 192.168.0.2 will map to one of the addresses in pool. Then one more client tries to use the internet in the LAN network, they will map to another public IP addresses, which is, for example, if you call this public address 1, this is 2. So if only 3 are available, 3 clients can be connected. If the 4th client communication, then you cannot have the communication established. So maximum you can have 6 public IP addresses. This solves IPv4 depletion to a certain extent, but not completely, because we are still giving a pool of public IP addresses on the WAN side, right? So this is not so useful, but still you can use the public IP addresses, keep changing it. Even hosting a web server on this particular translation type is not advisable, right? Because there is one LAN IP address which maps to one of the public IP addresses in the pool. So that is called as dynamic NAT. So it's not static one-to-one. So that is what with respect to dynamic NAT. Then the most used NAT type, NAT address or NAT translation type is PAT or NAPT, port address translation or a network address port translation, right? Here what happens, for example, on the LAN side, you have LAN 1 client 192.168.0.2, LAN 2 192.168.0.3. Right, like this you have many clients. It can be maximum 6 or 7, right, depending upon how many people are using the LAN or the home router. So once you want to communicate to the internet, this will translate to one public IP address, but the transport layer protocol will be different. For example, you take 4000 you say 4001, but this one same public IP address, but it will be 4002. So only the port is translated, right? So this really solves IPv4 depletion problem, right? Because there is one single public IP addresses on the WAN side, but only the ports keep changing. This can also be used for peer-to-peer gaming or peer-to-peer voice calls by having stun UPnP mechanisms. Stun, as I told, it's a predictive NAT. So once you start connecting, once you start the stun session, it will send a query to the stun server saying what is the public IP address and port they are using. Then it will send the predictive port, and then that can be used for the communication. But again, here one more thing, even stun cannot solve this problem, because for each communication one port is assigned, port is translated. For example, for stun, he says what is a predictive NAT for predictive NAT address translation. He says that 4001 is the port, public IP address is so and so, right, which is constant or which is single one, but the port keeps changing. But if when they actually use that thing, when they do the voice call, they may use a separate port on the WAN side. So this may create problem with respect to port. So that's why UPnP can be used. It is called as universal plug and play. So what happens is, we can ask on the LAN side a PC saying that using UPnP protocol, I want to reserve public IP address is same, it's a single one. I want to reserve this port. That port can be used to communicate for voice, for gaming another port. So, but you need to register it in the home router saying if a packet comes from this port, always translate it to 4001, and if a port comes from gaming console, translate it to 4002. So this is how most of the home routers have this mechanism, PAT/NAPT, right? So because they have universal plug and play, UPnP already installed in the home router. Stun server is not in the home router, it's outside, it's in the internet, right? So as I told, stun may not be useful, UPnP will be useful. So to recap, PAT is port address translation. Each connection, the TCP or UDP connection from the LAN side will be given a separate port on the WAN side. The public IP address remains the same for all the connections. So the next one is network address translation type. So we have CGNAT, so which is called as carrier grade NAT. Instead of translating the IP address, if you want to avoid IPv4 depletion at a maximum level, then CGNAT will solve your problem. But double NATing will definitely be problematic for peer-to-peer use cases, like for example voice calls or gaming sessions. But CGNAT also does not solve the problem. It solves the problem of IPv4 depletion because a double NATing is done. So LAN as a private IP address, private, then it translates at WAN. It is also private address. Then at the ISP edge router, it translates to public IP address. Right? So IPv4 depletion problem can be easily solved by using CGNAT, but it's not a good use. It does not have a good use case for gaming and peer-to-peer voice calls. So to recap, network translation types, NAT types depending upon the translation, are static NAT, which is one-to-one mapping, dynamic NAT, which is one-to-many from the pool of addresses, pool of public addresses. Third is PAT, port address translation, where each session, TCP or UDP session, is given a particular port, but public IP address is always the same. Then CGNAT, this is double NATing. One NAT is done at the NAT translation is done at the home router, and the other NAT translation is done at the carrier edge router, right? So what is the best method for solving the IPv4 depletion is CGNAT is the best because it uses private addresses on the WAN side also. Then comes port address translation, which does not solve. It does solve because there is only one public IP address, only the ports keeps translating. In dynamic NAT, we have pool of addresses, still we take few IPv4 public addresses. So that is also does not solve. Static NAT just does not solve the NAT issue or IPv4 depletion. So static NAT, IPv4 depletion is not at all solved. Dynamic NAT to a certain extent, but is a poor solution for IPv4 depletion solution. Then you have PAT, which solves IPv4 depletion problem, but not as good as CGNAT, which does double NATing, because you have private addresses on the WAN and also private addresses on the edge side. What is the best for peer-to-peer voice communication or peer-to-peer gaming console sessions? Static is the best. Then comes dynamic NAT, then comes PAT, then comes CGNAT. So that's how the use cases can be designed for network address translation types. So now next type of NAT is depending upon the behavior, what they do after establishing the NAT translation. The first one is full cone NAT. Here each address is translated to a public IP address. If external server does not, external clients, for example, who want to contact you, this home router, the clients behind home router, they need not send a packet. They can directly initiate a connection. So it does not require that internal LAN clients needs to have sent a packet earlier than the actual session is established to the external source. If a packet from LAN is received by the external host, then for sure you will have the full core NAT working, but the LAN side client need not, in full core NAT, LAN side client need not send a packet to the external host which is connected in the internet. External host can directly communicate to the LAN clients because the public IP address is fixed. That is what is full core NAT. So in summary, full core NAT does not need the internal LAN clients to connect to the external server. External clients can directly initiate a connection to the LAN clients. Then the next type is restricted address cone NAT. Here again, your private address is translated to a public IP address. That public IP address is used to communicate to the external server, but here it requires that an internal LAN client from which the connection is established, or external server, or external client trying to reach that internal client, should have sent a packet to that external client. If an internal client, LAN client, had sent a packet earlier using the public address to the external server or external client, then external client can only send the packet to internal client. That means initiation should be done by the internet, and that is address. Only address should be matching, right? So that's why it's called as restricted address cone NAT. Then next is restricted port cone NAT. It is similar to restricted address, only the difference is the internal client should have communicated over the public address plus the port. If the port is not matching, mapping in the home router, then external client cannot reach the internal client. So internal client should have sent a packet to the mapping, that is a public IP address and the port. So that's why it is restricted port cone NAT. Then the last one is symmetric NAT. This is the most strict NAT type that we have with respect to behavior. Here, each session, even though it is from from the same LAN client, the address mapping will be public address and a different port, public address and a different port, even though it's from the same client, right? So that's why it is symmetric NAT. Each session will have a public IP address and a separate port. So this creates a big problem for peer-to-peer and peer-to-peer gaming and peer-to-peer voice calls. That's why we use mechanism called as stun or VPNs to connect for a better user experience, right? So to summarize again, there are with respect to NAT behavior, there are 4 different types. One is full cone NAT, where an internal client does not have to send a packet to the external client to make the external client communicate with the internal client successful, right? That is full cone NAT. The public IP address is mapped to one particular public port. If that mapping is there and that is known for the external client, you can always communicate, right? Address restricted NAT, restricted address cone NAT, is when at least in the mapping, address should be used by the internal client to communicate to the external client. If then only external client can be able to send a packet to that particular address. So that is restricted address cone NAT. Then the third is restricted port cone NAT, where both address and port was used by the internal client to communicate to the external client. Then only external client can send a packet to that particular mapping. And third is symmetric NAT, where the peer-to-peer voice and peer-to-peer gaming sessions will be difficult to operate because each session will have one same public IP address but different ports, right? So we send a particular request to the stun server, but by the time it returns from the stun server for the actual voice call connection, it may use a different port than what is provided in the stun server. So that's why we will use VPN mechanism to solve the symmetric NAT problems for direct peer-to-peer voice calls and peer-to-peer gaming sessions. So these are the different NAT types that we have. So we will dwell deeper by having practical class how these NAT sessions create problem or useful to the gaming or voice calls. So to recap, with respect to NAT address translation, you have 4 types. One is static NAT, where is one-to-one mapping is there. It will not help in IPv4 depletion problem solving. Then there is dynamic NAT, where a pool of public addresses is chosen and assigned to the session. Then there is port address translation, where public IP address is same for all the sessions, but the ports keeps changing, right? Port is translated. Then there is CG NAT, which is carrier grade NAT, where double NATing is done, which is very good for solving the IPv4 depletion problem. With respect to NAT behavior, we have full cone NAT, where there is no need for the internal client to use the mapping to communicate to the external client. External client can directly use that mapping to communicate to the internal client. No need for the internal client to start the session. Then there is restricted address cone type, where at least in the mapping, address should have been used by the internal client to communicate to the external. Then only external server can contact the internal client. Then restricted port cone NAT, it requires both address and port to be used by the internal client to communicate or initiate the session to the external server. Then only you can contact the internal client. Symmetric NAT is the most toughest and strict NAT type, where each session is mapped to one public IP address and a separate port, right? So this is what I wanted to discuss as part of this class. Thank you for your time. Bye.